Yeah, we will discuss some examples of Markov models. So, Yeah, like there is a problem on nasal new, so don't worry. So I'll just wait one more minute before starting. Alright, so let's begin. Um, okay, I hope the you can see the screen change. Like I guess the screen is changing.
Yes.
Okay. So, this is week 3, and today we shall be talking about advanced smoothing, morphology, and post tagging. So, like, mainly the problems which I have today are based on advanced smoothing and post tagging, like Markov models. So, not as much of morphology here because that is relatively easy. So, let us start. Okay. So, firstly, you have this example of passage over here, and they have asked that choose the correct option, which is like you have to find out the probability of continuation for these two words, which is and in for the given text, and like you have to see how they compare. All right, so. All right, so because this is quite large, I'm going into the solution itself. So actually, let's see for and. So the word and, as you can see, it occurs 1, 2, 3, 4, 5 times. But um, we need to see how many unique continuations and provides. So we have abstract and, so they have asked you to ignore the punctuations and everything is in lowercase. So abstract and is one bigram, headings and, first and, section and. So this first and is repeated again, so that does not need to be counted. So the probability of continuation of this is 4 by b. So b is the total number of unique bigrams in this passage. So we do not need to count b for this particular question. Now we will look for in. So this is straightforward. There are 4 instances of in, and all 4 are like they are unique bigrams. So again, the probability is 4 by b, and that is why we can say that option C is the answer. So they are equal. So this is a relatively easy starting point into these kind of advanced smoothing models. So what you need to remember is that probability of continuation means you have to find the count of continuation. Count of continuation means number of unique bigrams this one continues in this case. So that is all. And although this is not difficult, but as you know that the probability of continuation, this is required in some other smoothing questions also. So that is why it's important to understand. So this is number of unique bigrams. All right, so now you are reading an article on sentiment analysis. So you encounter the words on the right. So you have encountered these words, and like they are, it's not like you have encountered them one after another. They can be in any order, but these are the number of times you have encountered each word. Say like these three words: sentiment, aspect, and opinion. You have seen them 5 times each. Triplet and extraction were seen 3 times each, and pointers, encoder, decoder, and network. These 4 words were seen once each. So now they are asking to find the MLE and good Turing estimate of reading architecture next. So after you have encountered these words, like there are 25 words over here, so you can understand 15 plus 6 plus 4. So after these 25 words, what is the like probability of reading architecture next? So would you like to have a go? So you can guess what can be the answer. Then we'll discuss. All right. So what should be the MLE? What should be the MLE? So the hint here is that you have not seen architecture yet. So the MLE of architecture should be 0 actually. And yes, like B is the correct answer. And then if you want to find out the good Turing estimate, so we know that we need to find number of times we see a word. Like this is as you know, for finding out good Turing, we need to calculate the frequency of frequencies. So number of words that occur once each. So frequency of once is 4. Frequency of thrice is 2. Like there are 2 words that occur 3 times. And frequency of 5. So 3 words that occur 5 times. So we need to calculate this first. And n is like the total number of words. So you have seen 25 till now. So you need to remember that it will be 25. And thus, so the P star GT is n1 by n, as you know, because this word architecture, it does not occur before this. So using the simple formula, you know this is n1 by n. If architecture would have been seen before, then the probability would have been different. But since architecture is occurring first time, so it is simply n1 by n. So 4 by 25. And MLE, as I said, it is the frequency of the word in the corpus you have seen so far. And you have not seen architecture yet, so that is 0. All right, let's move on to the next question. Okay, so this is going to be a slightly longer question. So this is based on linear interpolation. All right, so what are you asked to estimate? You have been asked to estimate probability of the nth word given n minus 1th and n minus 2th word. So like a trigram estimate. Wn is between these. So here A, B, C and D, these are all different words. So don't get confused with characters. Here these represent different words. So you have 5 different words for Wn. But for Wn minus 1 and n minus 2, we are only considering A and C. Alright. And if you see the table on the right, that shows the distribution. So for example, because we are only concerned about C and A before the current word, that is why you will see that finally the trigrams we want to estimate, like you have been asked to estimate trigram probabilities. So that is like CA, CAB, CAC, CAD and CAE. Like all these 5 different words given CA before. Alright. So these are the count of the bigrams. Count of the trigrams. This is the count of the bigrams, and finally this is the count of the unigrams. All right, and they have said that for the interpolation model, the weights of bigram and unigram models are 0.2 and 0.1. So you have to find out the trigram probabilities for all these, like A given CA, B given CA, and so on. All right. So first we need to find out the lambda for each of the terms, right? So if you know, in an interpolation model, we try to find out like all the possible gram n-gram estimates, and we give different weights to each of them. So for example, if we want to find out the interpolation estimate for a given ca, so one is this probability of a given ca, we weight it with the weight of the trigram model. Probability of a given a, we weight it by the probability of the bigram model, and probability of a, we weight it using the weight of the unigram model. So these three are three different weights. In the slides you may have seen it as 1, 2 and 3, so I have written it out tri, bi and uni for ease of understanding. And we know that all these three weights should sum to 1. Now they have already mentioned that the weights of bigram and unigram are 0.2 and 0.1. Alright, so 0.1 and 0.2, and so trigram is 0.7. Fine. Now firstly we want to do a given ca. So if you have a look over here, a given ca is 0. So no use of the trigram estimate. Then you need to consider a given a, that is also 0. And finally probability of a is like 10 by 50. So the last rows are like summing up the individual columns, and thus you get this value 0.02. It's pretty straightforward from here on. So then we will do it for b. So b has a non-zero value, so we have to put in the values over here. So 3 by 8 and 4 by 10 and 12 by 50. Okay, so somebody asked how the lambda is calculated. Well, if you look, they have said that weights of bigram and unigram models. So these weights are the lambdas. Lambdas are weights of the individual models. So weights of bigram and unigram models are 0.2 and 0.1. So lambda uni is 0.1, lambda bi is 0.2. That is already given in the question. So you need to find out lambda tri, and the thing is that all the three lambdas should add up to 1. So 1 minus 0.1 minus 0.2 will give you 0.7. Alright. So that is how we get the lambdas. Now definitely if these two values were not given, we would not have been able to calculate lambda trigram. So obviously when the question will be given to you, there will be enough data given so that you are able to calculate the rest. Okay, so B given CA is fine. This is C given CA. For D given CA, we again have the zeros. And finally, this is E given CA. So that is how we are coming to these possible values 02, 3665, 251, 008 and 3545. So that is the option B. So is this clear? Like for doing interpolation model, what you have to remember is that there will be a combination of unigram, bigram, trigram, like up to how many n-grams they have asked you to consider. So there will be, and you will have to calculate standard probabilities for each of the different parts. Like these are nothing, like this is not P star or anything, the things which will be used for the other smoothing models. For interpolation, it's simple probability. You just calculate the simple probabilities of each of the trigram, bigram and unigram models, and then you sum them up with the weights. So that is all about interpolation. In interpolation, you have to apply all the different models and the different weights. The calculation of probability is the simple straightforward probability calculation. All right. Okay, let's move on. Now we have back off smoothing. So again, it's the same corpus, everything is same, but now you have been asked to find out back off smoothing estimate for again C probability of A given CA, B given CA and so on. So the question remains the same, but this time you are asked to calculate back of smoothing. Now here they have asked that assume p dash x equal to px minus 1 by 16. So in the slides it was written as p hat x. There was some problem in notation, so I chose this. Whatever it is, what you need to understand is that this is the discounted probability. Like we in back of smoothing, what we do is that it is the concept of taking from the rich and distributing to the poor. So all the probabilities which are high, they get reduced by this value, and the zero probabilities, they get a share of that value. So that is the concept. So the modified probability or the discounted probability is the standard probability minus 1 by 16. So the notation here may be different, but it means the same thing as what you understand in back of smoothing. Okay. Now, if you recall, how do we calculate back of smoothing? So back of smoothing is like, so suppose we want to calculate, so before talking about that, so since this is a, like you have to calculate all the different values, we will be needing the both like trigram and bigram estimates. So because we will be needing both, so what we need to do here is that I am calculating all of them for everything. Okay, so now what happens is that we know probability of back off. How do we calculate? So we first see if that given probability is 0 or not. If it is not 0, we replace it with the discounted value. But if it is 0, we replace it with the weight times the probability of the bigram, or like one gram less. So if you so let me just show you so that then it will be easy. So I'll just compare with the formula you have seen so that you can understand how we are doing it. Okay, yeah. So you must have seen this slide in your like course. So as you can see, how they're mentioning it is that probability of back off. So if the probability is non-zero, or the count of that n-gram is non-zero, then we replace the standard, we just use the discounted value. So p hat, that is same as the p prime over there. So you use the discounted value if the actual probability is greater than 0. However, if it is not greater than 0, so if the probability is 0, what we do is that we use the back of estimate of 1 gram less. So here it was a trigram estimate, we replaced it with a bigram estimate, and it has to be weighted with a lambda based on that particular bigram. Alright. And then this is a recursive process. So similarly, you will calculate back off of the bigram model. So if the bigram probability is greater than 0, we just discount it. If it is not, then we use the unigram probability, discounted obviously, and then multiplied with the weight. Now the formula remains the same. The question here is, which must be like on your mind, is that how do we get the weights? So that I'll discuss. That is the main part about back off, is to calculate the weights. Because unlike the previous model where you were given like these are the values of two lambdas, so find the third lambda. Here there are equations which solve themselves, and you need to substitute the right values in the equations to get the values of the weights. So if you can see in the question, the weights are not given. So okay, till here it's fine, I guess. So how do we do it? So firstly, probability back off of A given CA. Now A given CA is 0. So we need to use the bigram probability. So we give lambda CA. So this lambda is based on this particular bigram. So lambda CA. Alright. And then we use the probability back off of the bigram thing, a given a. Now the interesting thing is that a given a is also 0. So since a given a is also 0, we need to replace this part, that sorry, PBO a given a, with lambda a, and then we use the discounted value p hash a, sorry, p prime a. So the main thing to understand is that there are two different lambdas over here. All right. Why is it so? Because if you remember, this is our lambda ca, this thing, and this is our lambda a. So I have just replaced these terminologies wi minus 1 and everything with the actual bigrams over here. That is what these things also mean, but it can be a bit confusing with the notation, so I am just specifying that. All right. Sorry, why did I end up over here? Yeah, so this is what we are getting for a given ca. So if you see, now we have to find out like p prime a. So like probability of a is 10 by 50, and we have to minus, like, discount 1 by 16 from it. All right, and we have these two variables. We will keep them now. Later on we will solve the equations and then get the actual values. All right, so yeah, so and I'm keeping them in this fraction form so that the values are easier to understand. Okay, so this is 11 by 80 lambda ca lambda a. And what is the bigram estimate? So the bigram estimate is simply lambda a. The lambda ca part is not there. All right.
Hello,
Yeah.
hello. Am I audible, sir?
Yeah.
10 by 50 I understood, that is probability of A, but minus 1 by 16, how it is minus 1 by
So
16?
can you look here, like, at the question? So in back of smoothing, we need to discount the probabilities. The actual probabilities are discounted.
Okay.
So what is this discounting? Let me go over it once more. So what happens is that, why are we doing back of smoothing? So the problem is, as you can see in this case, there are many counts which are 0. All right. So if we were using a pure trigram model without any kind of smoothing, then this probability of like a given ca, that would have been 0. Fine, but we don't want 0 values because they are not realistic, so we want some smoothened out values. So how that smoothing is done is that in back off, what we do is that back off is a idea of discounting from the rich and giving to the poor. So who are the rich? The non-zero values. And who are poor? The 0 values. All right. So that is why in back of models we always use the discounted probability. And this discounted probability, whatever you are discounting from any part, that actually goes and like forms a part of the non-zero values. So like if this was no back off, probability a given ca, that would have been 0. But due to back off, this will get some value, right? So we know at the end all the probabilities have to sum up to 1. So that is why whenever we are giving some probability to a event which actually is 0, then we need to deduct some probability from elsewhere. So how much will be discounted, that is usually given in the question. So here you have been given that the discounted values of probabilities are like minus 1 by 16.
Means in the question, they only give as the
Yes,
assumption, right?
yes, yes,
Oh,
yes,
okay.
yes. They will say how much to discount. All right, fine. So this is how we get this value, and I hope you can understand the bigram thing is also very similar. Now you will understand. Here we want to find out back of b given ca. Now b given ca is non-zero, so that is why we can directly use the discounted probability. So this is the idea. We are discounting from the rich and it gets distributed back to the poor. That is how it works. So you do see 3 by 8 minus 1 by 16. This is straightforward. And similarly, back of b given a, that is 4 by 10 minus 1 by 16. Now, as I said, I am repeating once again. For the problem, you have been asked to find out like P probability back off of A given CA, B given C, and so on. So why am I writing the bigram ones also? Because they will be needed to solve the equations. That is why I am just writing over here. Alright. So C given CA is also similar. You can understand. This is non-zero. So we directly no. So somebody asked a question that there is some problem about which is getting substituted where. So I am not talking about which is getting substituted where. What I am talking about is this. So this is the value you want to calculate, and the condition is whether the standard probability or the count is greater than 0 or not. So if it is greater than 0, we use this value. That is what I meant by substitute. We use this value. If it is 0, then we use this value. So that is what I was meaning by substitute. So I'll go over it once more so that you can understand. So just look at these two examples back to back. So B given CA. Alright, so probability of B given CA is, we know that B given CA is non-zero. That is why we use the discount form, like there were two conditions, 0 and non-zero. So we use the condition for non-zero, which is you directly discount the given probability. So that is what we are doing. And the other scenario which you were asking is when the probability is actually 0, A given CA is 0. So that is why we use the other, like the condition now becomes different, so the other value is used. That is what I meant by used or substituted. Don't get confused. I am using the very formulas which have been taught to you in the lectures. Alright. So when it is 0, we use lambda into probability of the lower n-gram. So it was trigram, we use probability of the bigram when the actual thing is 0. When it is not 0, we directly use the the discounted value. Alright. And it is recursive, like you keep on applying it until you reach the unigram level. Okay. So fine. Alright. So C given CA we also calculate like that. D given CA, it's 0, so we follow the process similar to A, and you will get finally like lambda, there is a lambda CA and again a lambda A. So you can see that because you have to calculate given with respect to the same bigram or trigram, so at the end there is always CA, or here it is always A. That is why the lambdas are in terms of those exact things. Okay. So here we get this value 7 by 400 lambda CA lambda A, and this one is 7 by 400 lambda A. And finally we also do the same thing for E. So now we have got 10 different values with the lambdas and everything. So 5 values for the trigram estimates and 5 values for the bigram estimates. Alright. Now herein comes the main part. If you add up all the bigram estimates, you will come to 1. Right? Because when you add up, everything is based on given A. So given that you are seeing A, probability of A next, probability of B next, probability of C next. So all the probabilities will add up to 1. And this is where you have to use these equations to find out the weights. That is why the weights are not told to you in the question. Because you can use these equations to find the weights. Alright. So because you can do that, so we first do the bigram part. So we use these values, and these are the values directly used from what I've calculated over here, like because I have written it out like this so that you can compare with the previous ones. So there are two terms with lambda A, which are this A given A and D given A, because those are 0. So that is why they contain the lambda A term. The rest are constants. So this is this is simple mathematics, and you get lambda A as 75 by 62. Okay, so hold on then. Now we need to find out lambda CA. For finding out lambda CA, we apply the same process. And this time we are doing the trigram probabilities. So adding up all the trigram probabilities should give us 1. And that is what we are doing over here. Again, we have two terms with, alright, not two terms. So if you remember, let's just go back a bit. So this is 11 by 80 lambda CA lambda A. Now we have already calculated lambda A. That is why in this equation you will see 11 by 80 into 75 by 62, which is the value of lambda A, into lambda CA. So these were constants, 5 by 16, 3 by 16 and 5 by 16 again. And this middle one is again 7 by 400 into lambda A, which is 75 by 62 into lambda CA. Alright. So again in this equation we have put in the value of lambda A, and then we can solve for lambda CA. So lambda CA actually comes to 1. So now you know the value of lambda A, you also know the value of lambda CA. Now you can calculate all the individual trigram probabilities which they have asked you in the question. And that is what we are doing over here. So A given CA is 11 by 80 into lambda A into lambda CA. That is coming to this. Similarly, this one 7 by 400 into lambda A into lambda CA. The rest were already calculated, right? So that is why the answer comes to A. So I'll just take a halt and do tell me if there is still any confusion regarding how to calculate back off. That is not in my hand. So somebody said if this question is asked in the exam, it will consume a lot of time. So that is not in my hand. I am just preparing you if it comes. All right. And it won't take that much of time. Usually the values are given in such a way that they don't become too ugly or something. Okay. So just remember what you need to calculate. That's all. Don't get confused, and then you can find them out. So you have to do it in a systematic way, then it will help you only. So like I did A given CA and A given A, all these things I did at the same time, and then I just added them up. So somebody has asked if I can provide questions for homework. That is not really part of what I am supposed to be doing, but I'll communicate with the other TAs for the course about this. All right. Okay. So I think back off is more or less understood. Now we'll go to Naser smoothing. So again, it's the same corpus, it's the same data. This time it's not that much complex. You just have to find the Naser probability of B given A. Yes, this document will be shared after the end of the discussion. So consider D is 0.75. So again, I'll refer to the slides so that there is not much confusion. So this is the Naser smoothing formula. It looks very, yeah, the YouTube links also get provided. So no worries about that. Okay, so this is the slide for Naser. Now when you have a look at this, you might find that it looks very intimidating. So instead of getting intimidated, let's walk through these individual portions one by one. All right. So you are asked to find Wi, probability of Wi given Wi minus 1. And here is this big thing. So first, let's consider probability of continuation Wi. Okay. So I'll go straight there. So you have been asked PKN B given A. So first, probability of continuation of B. So how many bigrams does B complete? So that is, there is only one bigram which B is completing. that is this AB bigram, right? So that is only 1 divided by total number of unique bigrams. So how many unique bigrams you have in the corpus? Okay, so you have A does not exist and AD does not exist. Remember that. So you have AB, AC, AE. These three you have, and one more is there, that is CA. So CA, AB, AC, AE. These are the 4 unique bigrams. These two are 0. That is why they are not here. So probability of continuation of B, you have to count the numerator and the denominator. So that is 1 by 4, which is 0.25. Okay. Next, there is a lambda. Again, I'll go over there. This is a bit laborious, but okay. Lambda. So you have been given lambda is based on the, like here it will be lambda A. So it is based on whatever you are conditioning the probability. So over here that is D by count of Wi minus 1 into this thing. So what is this thing? This is basically number of unique bigrams that W completes. So sorry, number of unique bigrams that start with Wi minus 1. This is what this part means. So number of unique bigrams that start with Wi minus 1. So that is what you have to find here. So D divided by count of Wi minus 1 into number of unique bigrams that start with Wi minus 1. Okay. So we again go here. Sorry for this inconvenience, but there are some other issues, that is why we have to do like this. So you have been told that D is 0.75. So this is 0.75 divided by count of Wi minus 1. What is Wi minus 1? That is A over here. So 0.75 divided by count of A, number of times A occurs in the corpus, into number of unique bigrams that start with A, right? So how many unique bigrams start with A? We have AB, AC and AE. There are 3. So it's 0.75 divided by 10 into 3, which comes to 0.225. Finally, this is the main part. So Nazarni be given A, you know, that is like we have to take the max of, like we have to discount the count over here. We have to discount the count by the D value which is given over here. So previously in back of smoothing we discount the probability. Here the count itself gets discounted by D. So count means frequency. Alright. So frequency gets discounted. So frequency of AB, so that is the bigram you want to find out. So frequency of AB minus 0.75, and if the value goes below 0, that is why this max condition is given. And you divide this with the actual count. Alright. And you add the other part with it. So this is how we do. So you know count of AB. So count of AB is 4. 4 minus 0.75 is 3.25. 3.25 divided by count of A, which is 10. And then you add these two things, multiply them together as we have calculated, and you get this value 0.3813, which matches with option D. Okay, so somebody had a question, like initially they said about Nazarni. So is it clear now? Okay.
Can you tell me why you took CA in the denominator? Like, I mean, in P continuation.
Which one?
In
This
P
part
continuation, you took CA, right? I mean, it's 0, but
no. Which one are you are talking about? This problem, right?
yeah, I'm talking about P continuation of B.
Huh?
In the denominator, the count of AB divided by, why do you have CA there?
Okay, P cont B is confusing. Okay. So let's remember what P cont means. So P continuation means how many unique bigram B completes. So how many unique bigrams end with B divided by total number of bigrams in the corpus. So this is what you have to understand. So
Okay.
okay, like total number of bigrams. That is why we have to. So when you are looking at bigrams, you cannot look at the right hand column because that is unigram. So start looking
Yeah.
from here. Okay, so if you look in this column, we have three bigrams: AB, AC, and AE. The rest was zero. Okay,
Yeah.
so AB, AC, and AE is there, but you cannot just end by looking here. You also have to look at this side. So CA is also a unique bigram, right?
Okay.
So yeah, like that part is tricky, I understand, but
Yeah.
you need to understand why we are including CA. So the remember once again, the probability of continuation is number of unique bigrams that end with B divided by total number of unique bigrams. Now
Okay.
because CAB exists three times, so that means CA also exists, right? So that is why we have
Yeah.
to take CA over here. But
Okay.
lambda A is different. In lambda A, we are trying to see how many bigrams start with A. That is why CA does not figure here, right?
Okay.
Okay.
Yeah. Thank you.
So is pcond be understood, or should I go over it once more?
No, it's understood. Yeah.
Okay. So somebody said these questions are not in the assignment. These questions are not from your current assignment. These are from previous year's assignments based on these topics. So this year's assignments you are supposed to solve yourself. Like we are not supposed to be discussing this year's questions. All right. So these are questions of previous year. So in previous year these questions were given as assignments, and that is why we are using them as a template to discuss with you.
Hello, sir.
Hmm.
Is there any chances of getting these type of questions in final exam?
That I am not very sure. That the instructor and the other TS will be able to say. So we have just been asked by NPTEL to give you these sessions based on previous year's assignments, so that you are able to solve this year's assignments in a better way, or you are able to understand them clearly before solving. That is the purpose of these sessions. Okay, so all these kind of doubts you should redirect towards your normal TAs, like in your course TAs and the discussion forums over there. All right, like they will be able to give better answers to these questions. Okay, so pcond B is clear. This is also clear, I guess, and the final one we have just applied the formula directly. Okay, all right. So before I go on to the Markov models, I just want to say one thing, that you remember the overall idea about the individual smoothing, because that can get confusing. What is Bekov, what is Nezarny, and they use some similar concepts, so all that can become confusing. So remember, interpolation means you will have trigram, bigram, unigram, all the three models, and you combine them with different weights, and each individual probability which is used, those are not discounted or not changed in any way. Whatever probability you calculate directly, you use them, you just multiply them with the respective weights. That is about interpolation. No discounting, nothing. Okay, fine. In back off, we have to discount. How much to discount usually is mentioned in the question in that form, like minus 1 by 16. In that form it is mentioned in the question. So, and how to get the individual weights? Well, the sum of all trigrams and bigrams that begin with a particular section will be 1. So like probability of anything given A, sum up all those probabilities, you will get 1. Like summing up probability of anything given CA, that will give 1. So you need to leverage those formulas to calculate the weights. And yeah, I can understand when you see these questions it becomes very confusing at first. So yeah, as far as I can say, back off really requires time to calculate and understand, because you have to find out all the things. But interpolation and Nezarny are relatively easier. You for Nezarny you just need to remember that on one hand you have probability of continuation, okay, where you see here the numerator is how many bigrams B completes, and whereas for the lambda A you need to see how many bigrams start with A. So that is the only tricky thing you need to remember. This part is total number of bigrams, so at least the remembering the formula is easy for this part. Yeah, there is this trick. You need to also count or take into account whatever bigram is there in the higher order n-grams. That is why the CA comes in. Otherwise, in this formula, the only confusing part is for P cont B, you have to find out in the numerator number of bigrams completed by B. Whereas for lambda A, you have to find out number of bigrams started by A. That is the main confusing thing. So if you get that clear, then rest of the formula is relatively straightforward. That is the only thing you have to, not the only thing, but that is the most important thing you have to keep in mind. Okay. All right. P cont AA. So when you are talking about P cont AA, so somebody asked in the chat, what about P cont AA? So when you are talking about P cont AA, then you cannot think in terms of bigrams anymore. You have to think in terms of trigrams. So number of trigrams that end with AA, 0. Okay. And number of divided by total number of unique trigrams. Unique trigrams is 3. So that one actually comes out to 0. That somebody asked probability of continuation of A. So when you have been given a single, like this is a unigram B, because this is a unigram, you have to estimate everything in terms of bigrams. If this were a bigram itself, say A or AB, then you would have had to find out in terms of trigrams. All right. Okay. So we don't have much time. We need to cover another important area. This is the Markov models. So I am going straight to that. All right. So before I start with the questions, I am giving just a high level insight of a Markov model. So Markov model means like any one state is dependent on some previous states. How many previous states? That depends on the order. First order Markov model means it depends just on one single previous state. Second order means two previous states. Thus, that has some similarity to how we think about bigrams and trigrams, right? So a bigram model is like a first order Markov models. Like there is a similarity between that. Don't take it literally. That is how you need to think about it. Okay. So first, like in today's assignments, like today's session, we'll only talk about first order Markov model, but higher order Markov models also work on the same concept. Okay. So now about first order Markov model. So that means each state. So what is a state? So state means, okay. So here you have two kinds of things. There is something called a state and also something called like observation or emission, right? So what is this observation or emission? So ideally state is something which is hidden and observation is something which is actually exposed. So based on that, what you can consider them as is that state is the internal property, whereas emission or something that is the external property. Okay. With that out of the way, I'll go into the question slowly one by one, and in between I'll also take doubts, so don't worry. Okay, so when you are given a diagram like this, what you need to understand is that these individual like circle things, whatever is represented here, those are the individual states. Okay, and the relation is between states always. Like you can move from one state to another. And what is this thing about emission? Well, emission is like a property that you observe from a state. So like for example, there can be some actions like if sunny, wear a cap, if rainy, take an umbrella. So taking an umbrella is the external action or the emission, or wearing the cap is the external action or emission. So those will depend on individual states themselves. There is no question of transition between them. The transition is only between the states. I understand that there can still be some confusion regarding the state and the emission thing. So we will see in the example. Okay, so let's start with this problem. So this is a first order Markov model. Okay, and you have three possible weather conditions: sunny, foggy, and rainy. And they have said that this is a first order Markov model. What does that mean? It means that the state only depends, like, on for a day. These weather things are mentioned for a day. So weather of today will only depend on weather of yesterday, not day before yesterday and before that. Why? Because this is a first order Markov model. So the weather at any day is only depends on the weather of the previous day. Okay, and these are like the changes. So today is rainy, there is 0.6 probability that tomorrow will also be rainy. There is 0.2 probability that tomorrow will be sunny, and 0.2 probability that tomorrow will be foggy. So that is how you need to read these arrows. So that is probability of going from rainy to sunny, probability of going from rainy to rainy, probability of going from rainy to foggy, and so on for the other things. All right. Okay, so they have asked that assume that yesterday and today are both foggy. So yesterday was foggy, today is also foggy. Find the probability for sunny. Actually the question, there is, like, I did not correct the question. So the actual question is probability for sunny day after tomorrow, not tomorrow, day after tomorrow. Okay, so you have yesterday, you have today, you have tomorrow, you have day after tomorrow. There are 4 days. All right. So let's have a look over here. Today, yesterday, today, tomorrow, day after tomorrow. Now you need to find out the weather for day after tomorrow. Okay, so before going to day after tomorrow, let us think about tomorrow. The weather of tomorrow will only depend on the weather of today, not on the weather of yesterday or something else. So we can find out weather for tomorrow based simply on weather of today. That is the property of first order Markov model. So given that, so how you need to do? So today is foggy. So here the trick in this question is the weather of yesterday is also given, but that will not be needed in the equations. And once again, I'm again correcting this, that this is actually not tomorrow. The actual question is day after. Oh, here it is, day after tomorrow. Okay, fine. So all right. So here you have the weather at today is F. So first we need to find, so probability that day after tomorrow, so DAT means day after tomorrow, probability that day after tomorrow is sunny. How to calculate? So individual parts first. So first today is foggy, probability that tomorrow is sunny into tomorrow is sunny given, tomorrow is sunny, then the probability day after tomorrow will also be sunny. So first we are considering what are the possible weathers for tomorrow before we jump into day after tomorrow. So for tomorrow we can have sunny, foggy or rainy. We don't know that. We just know today is foggy. So probability that tomorrow will be sunny given today is foggy into probability day after tomorrow will be sunny given tomorrow is sunny. So this is a chaining of the probability conditions. I hope you can understand. All right. So because this is a first order Markov model, this,
Excuse me, sir.
yeah,
What is that DAT? DAT?
day after tomorrow.
First.
Day after tomorrow.
So D stands for D.
This D stands for probability that today, like whether today is sunny. Like I just representing the weather of today using this weather of given day. Okay, not today. Weather of day after tomorrow, weather of tomorrow, weather of today. Okay, so you could have used W as well. That is all I want to say. So this D is the indicating the weather. Okay, weather of that day, which is the state of this given problem. Okay, fine. So then this is the first like there are 3 possible scenarios, that tomorrow we know today is foggy and we want to find the probability that day after tomorrow is sunny. So the only day in between is tomorrow. So tomorrow can be anything, so we need to consider all the probabilities. That is why probability day after probability that today is foggy tomorrow will be sunny, and then day after tomorrow will also be sunny. That is one situation. Second situation, today is foggy. What is the probability that tomorrow will also be foggy? And multiply that with day after tomorrow is sunny, given that tomorrow is foggy. So why we are writing it like this is because the weather at one day depends only on the weather of the previous day. That is why we have to chain them like this. Okay. And finally, this is the rainy situation. All right. So that is how you find the, like, this is like you are, this is just simply expanding conditional probability formulas, nothing else. The trick happens is that because this is first order Markov model, like we can forget the previous values after. Like when we are doing day after tomorrow is sunny, given day of like tomorrow is sunny, we don't need to see today, yesterday, and so on. For this part, we do not need to see yesterday. So if you take this original equation and you solve, like mathematically break down the probability equations and all, you will get this very same thing. Okay. So this is just, I'm substituting the values directly from the graph. So these are like, you have these values over here. So we are just putting it over here and we get these. Okay. So this is not a very difficult situation because here you only have the state, like whether the day is sunny, foggy, or rainy. There is no other variable to think about. But in the next problem, you will have that. And that is why you have to get the idea clear, like what is a state and what is an emission. Okay, so this is the next problem that is also based on the similar thing. So again, we have this very same diagram. All the values are same. But now you are supposed to feel an emotion based on the weather of the given day. And this emotion is the emission or the outward property or whatever you call it. So sunny, foggy, rainy, these are the states. Whereas happy and grumpy. So if you see the question, find the probability of the sequence of being happy on day 1 and grumpy on day 2. So apparently here you have some emotion which is based on the state. Like this is the emission and this is the state. So happy, whether you feel happy or grumpy only depends on what the weather is today. It does not depend on what you were feeling yesterday. So I hope you can understand why these are states and these are emissions. Emission only depends on the state, but transition can happen only between states. So there is no transition from H to G or G to H. These are only based on whatever is the state. The transitions are between the states themselves. So that is what you need to get clear about this. Here it may be said in a very simple way, but like that is the main idea. There is one internal property which is the state, and there is a probability of transition between the states, and there is another external property which is the emission, which only depends on the current state. It does not depend on anything else. But what you usually, the problems will be that you have the emission values or you need to calculate them. So you need to understand this interdependence kind of between the state and the emission. Okay. So this will take a bit of time. So I'm just walking through it slowly. So they are saying that find the probability of the sequence. So there is a sequence of emotions. What is the sequence? Happy and grumpy on day 1 and day 2 respectively. So you will feel happy on here. There is no more today, tomorrow, day after tomorrow. So there are just day numbers. So day 1, day 2. There are 2 days, day 1 and day 2. And what is the probability that you will be happy on day 1 and grumpy on day 2? Like what is the probability of this sequence? Then you are given initial probabilities. That is on day 1 probability of the weather being sunny, foggy and rainy. Alright. So you have day 1 values and you have these values which represents the probability of being happy or grumpy based on whether it is sunny, foggy or rainy. Okay. And what you have to do, you have to find the probability of this sequence of being happy on day 1, grumpy on day 2. So how do we do this? So if you look over here, now I have a new notation. What is this new notation? This is this E. So E is the emission, as I said. Or here we can say, like, you don't need to think what is the variable I am using. So here I am using E, you can use anything else, but more or less this is what I mean is that this is the emission and this is the state. Or for the given problem, this is the weather of the day and this is the emotion that you feel. Okay, fine. Now, what is the probability of you feeling happy given that day 1 is sunny? Happy on day 1 given that day 1 is sunny. That is probability that day 1 is sunny into probability of being happy given it is sunny. So these ones are the initial probabilities they have mentioned. So day 1 being sunny is 0.5 and given that it is sunny, you feeling happy, the probability is 0.7. Similarly, we get the other two. Okay. Now it gets trickier. This is about day 2. So probability of you feeling grumpy on day 2, given that day 2 is sunny, and also whatever be the possible values for D1 and E1. This is what you have to remember, what this means. This statement, like this thing means that probability that you feel grumpy on day 2, given that the weather of day 2 is sunny, and whatever were the possible conditions for day 1 and E1. Okay, so firstly we have to go one by one. So why we are doing G over here? Because that is what we are asked to find. So don't get confused. Why we are putting E1 equal to H and E2 equal to G? Because that is what the question asked us. Happy on day 1, grumpy on day 2. So we are calculating just that. So we calculated the probabilities of being happy on day 1, irrespective of the conditions. Like if it is sunny, then it is this. If it is foggy, then it is this. If it is rainy, then it is this. Okay, now we want to find out the probability of feeling grumpy on day 2, given that day 2 is sunny. We'll also do with foggy and rainy. So let's look at this one first. So this is, you have to chain out the probabilities. So what are they saying? They are saying that you feel that day 2 is forget about E2 for now. Look at D2. So you have to give D2 as S. That is D2 is sunny. So you know that we need for the problem that E1 should be H. That is, you are feeling happy on day 1. So E1 is H and D1 is S. Into D1 is S and D2 is also S. So see, the transition happens between the states. The emission is from the current state only. The E's are only, EX is based only on DX, but DX is based on DX minus 1. That is what I was trying to emphasize. So again, here we will consider all possibilities. If day 1 was sunny, then this is the thing. If day 1 was foggy, then this is the thing. Like you are feeling happy on day 1, which is foggy, then probability of going from day 1 as foggy to day 2 as sunny, and finally feeling grumpy on current day, which is sunny. So G given S, this last value comes directly from here, E2 given D2. Okay, fine, and I'm just adding them up, so we get this value. So here, instead of looking at the exact values themselves, what you need to understand is how we are calculating. So this is just one part. We have not yet gone to the entire part of how grumpy I am feeling. So this is only based that I am feeling grumpy on day 2, given that day 2 is sunny. Now we also need to find out what happens if day 2 is foggy, if day 2 is rainy. So those are the other two equations. If day 2 is foggy, then you just need to, here day 2 becomes F. So you have all possible conditions for day 1, S, F and R. And in all cases, you are going from those, from S to F, from F to F, from R to F. And finally, this one. Probability of grumpy given foggy. That comes to this value. And finally, given rainy, we do the same process. We get this value. Now, here comes the total part. Probability that day, like I feel happy on day 1 and grumpy on day 2. No more conditions, nothing. This is the final value we need to find out, right? So that is the addition of the three previous things we calculated. Okay, so like you feel grumpy given it is sunny, given it is foggy, given it is rainy, and given all possible conditions of D1. So that is why we calculated these three values one by one, and we will add them up, and that gives the final answer. Okay, so bit confusing, I can understand, but I can assure you, if you go over the problem and look at the exact ways I am calculating them, you will be able to understand why we are doing what we are doing. Again, let me just tell you about the confusing parts. So when you do it for day one, you need to only consider the state of day one. So emotion on day one is based on state of day one, and you do it with the initial probability into probability of going from that to there, like being happy given it is sunny. So this one is straightforward. And why are we doing only E1 equal to H? Remember, we are not calculating E1 equal to G because we don't need it. The question asks that E1 will be H. So we don't need to find out the probabilities of E1 being G. Okay. When we do E2, then again you have to do for all possible values of D2. So E2 is G, but D2 can be S, F, and R. So that is why you need to vary that. And then you need to vary the transition between the states. So if you look at these three equations, only the middle part changes. That is the transition between the day. The emotion on the first day, that part does not change in the three equations, and emotion of current day given state of current day, that also does not change. Only this part changes. And why this part is changing? Because we are considering different values for D2, and each value has to be based on every possible value of D1. So as part of these three slides, we are actually looking at all possible values of D1 and D2. If you see, so over here D2 is S, we have all combinations of D1. D2 is F, all combinations of D1. Again D2 is R, all combinations of D1. So that is the main part what it is happening. So if you just think with a calm head, you will be able to understand which probability is coming from what. Okay. All right, I just have one more question which is related to this very problem. So let me just discuss that quickly before I take more questions. Okay. So this is slightly easier. So you feel grumpy on day 1, happy on day 2, happy on day 3. So they are saying that you are having these emotions. Day 1 is grumpy, day 2 is happy, day 3 is also happy. What is the probability that all the days were sunny? Okay. So this is what they have asked. D1 is sunny, D2 is sunny, D3 is sunny. Given E1 is grumpy, E2 is happy, E3 is happy. So you need to again follow the same way of doing it. So you are trying to find out of each day being sunny. So probability that day 1 was sunny into okay, so this is also a slight mistake. There will not be a plus sign over here. This is also multiply sign. Like everything is getting multiplied because you are calculating in a one single chain. Nothing gets added over here. This is multiply sign. I want to correct that. So that you will see in the next part that all the signs are multiplication. There is no addition symbol over here. This is also multiplication. By mistake, I forgot to change it. Okay, so day 1 is sunny and you feel grumpy on a sunny day. Into day 2 is sunny given day 1 is sunny. Into feeling happy on a sunny day. Into day 3 is sunny given day 2 is sunny. Into happy on a sunny day. So this is just a simple multiplication of all these values and you get this. Okay. Alright, so this question is just this much only. So not more than that. So okay, now I have finished this part. So tell me if you have any queries regarding this Markov model thing. So we have not done post tagging over here exactly, but this is Markov model is what post tag is based on. So as I was saying, the current word is the state and the tag which you give, the part of speech, that is the emission. That is the external thing which you can see. So that is like, I'm again trying to equate how happy and grumpy and this sunny, foggy, rainy, what they actually mean or how you interpret them if the problem was something different, not about the weather and emotion. So in post tagging, the states are the words, and these are like the probability of the word being a verb or a noun or whatever. So the tag. Okay, so that is about first order Markov models. So if you have any doubts, you can ask. So once more, I am repeating this. First order Markov model means the emission will only depend on the state. Emission of a current, like if you have state like S1, S2 and so on, and emissions E1, E2 and so on, then EI will only depend on SI, on nothing else. Okay, but SI will depend on SI minus 1. That is the main idea of how you resolve the conditional parts of the probability. E will only, like the in this problem, E will only depend on D. So EI will only depend on DI, and DI will depend on DI minus 1. So this is the only dependency parts that you need to understand. So you put in the probability equation first and then you solve one by one, like all the other things are independent. That's all. So this is how it gets solved. Like even over here and also the previous problem, that is the exact thing we were doing. Okay, so is there any doubts regarding the Markov model part? Yeah, I think I gave my email ID the last day also.
Can you send this video link in a chat box?
The video has not yet been uploaded, so once it gets uploaded you should be able to see it from that main links which you have. So last class also, like somebody was asking, so in your course, like that where you access the NPTEL course, over there only you will get a link to, like there is a spreadsheet, and in that spreadsheet all these links are given. So that resource is available inside the course only, so you just need to check that one out. So previous day somebody actually pointed out where they were exactly, I don't remember. But yeah, like some students have been able to find that out. So it's there in the course page only. Over there only you will get it from somewhere. So all our videos and these slides are posted regularly, like after the sessions. Okay. Okay, then I guess I'll take leave for today. And yeah, we'll meet next week. All right. Thank you.